Okay, in this video, we're going to take a look at areas of sectors of a circle. So to first define what that is, it's a region of a circle that's bounded by a central angle in the intercepted arc. The easiest way to think of a sector is think of like a slice of pizza or a slice of pie. You always cut to the center. Your sides are going to be radii, and then the crust on the outside part there, that's kind of like that intercepted arc. So here with circle A, I have that shaded sector. I also have a non-shaded sector. That's the remaining portion of that circle. So we're going to look at the area of those parts. So you might wonder, how do we find that area? If you think back to how we found arc length, we looked at the total length, the circumference, and we took a certain fraction of that length. That fraction was determined by the central angle, or we could also say the arc measure, same thing. So for area, it actually works the exact same way. We're going to take the same fraction, except we're taking a fraction of the area instead of a fraction of the length. So area of a circle is pi r squared. So our area formula for a sector, that's going to be central angle divided by 360 times pi r squared, because again, our area formula for a circle is pi r squared, versus arc length back in chapter 10 was 2 pi r, because that was part of our circumference. So how's that going to work in practice? Let's say I have this diagram here. It looks like I have that shaded sector. The radius is 10 yards, and then that big arc measures 310 degrees. So if I wanted to find the non-shaded area, I could just plug into the formula 310 over 360 times pi times 10 squared. And then that would definitely be a rounding question. Type all that in, use that pi button. You can use 3.14. However, since we're going to get some pretty big numbers multiplying pi, it's best to use that pi button because you'll get a better approximation. If I wanted the shaded area, then I would do 60 over 360. Actually, that should change to 50. I don't know why I put 60. That angle is definitely 50 degrees because I have 50 degrees left over to make a full rotation. So just make note of that. It should be 50 divided by 360 times pi r squared. All right, one other part of this section are these things called segments. So a segment of a circle, it's basically a portion of a sector. So if you were to make a sector and then you connect where your radius touches your circle, and then the other radius where that touches that circle, that shaded portion there, we call this a circular segment. So we want to find the area of that. To find the area of a circular segment, what we're going to do is take a look at that entire sector here in red, and then we'll just subtract off the area of that triangle. So it's going to be angle over 360 times pi r squared minus 1/2 base times height. So area of that triangle, that's going to be found multiple different ways. We're going to have to go back and remember all those tricks we learned back in 11.1, where we might have to use SOHCAHTOA, we might have to use 30, 60, 90, we might have to use Pythagorean theorem. So finding the area of each of those parts, the sector and the triangle, are necessary in order to get the area of that segment. That should actually get you plenty of information to get started on the questions for 11.3.